Hi guys, today I'm going to discuss about the summary of the chapter 7, which is the IP addressing. In this chapter, in this chapter examines in detail the structure of IP addresses and their application to the construction and testing of IP networks and subnetworks. So the we have the IPv4 addresses. The IPv4 is addresses. So binary is important for us to understand because host servers and network devices use binary addressing. So especially they use binary IPv4 address if they use binary IPv4 addresses. So by working with binary numbers can be challenging for ease of use by people. So IPv4 addresses are commonly expressed in dotted decimal notation. Um, so uh, like in positional notation, learning to convert binary to decimal requires an understanding of uh, positional notation. So positional notations means that a digit represents different values depending on the positions the uh, occupies occupies in the sequence of numbers. So you already know the most common numbering system. So this the decimal based 10 notation system. So um, to convert a binary IPv4 address to its dotted decimal equivalent, so divide the IPv4 address into 8-bit octets. So next is to apply the binary positional value to the first octet binary number and calculate accordingly. Um like in decimal to binary conversion. Um it's also necessary to understand how to convert a dotted decimal IPv4 addresses to binary. So a useful tool is the binary value table. The following, so that's the, and to help understand the process, consider the IP address, for example, 192.168.11.10. So using the previously explained process, so start the binary positional value table and first decimal number 192. So for the next one, the IPv6 network addressing, um, the need for IPv6. So the definition of IPv4 addresses space has been the motivating factor for moving to IPv6. So as Africa, Asia, and other areas of the world become more connected to the internet, so there are not enough IPv4 addresses to accommodate this growth. So IPv4 has a theoretical number maximum of 4.3 billion addresses. So private addresses in combination with network access translation or the NAT or NAT has been the instrumental in slowing the deflation of IPv4 address space. So however, NAT breaks many application and has limitation that severely impede peer-to-peer communication. So everything of internet. So the internet of today, it is significantly different than the internet of past decades. So like the internet of today is more than email, web pages, and file transfer between computers. So the evolving internet is becoming an internet of things. So no longer will the only device ac- accessing the internet be computers. So and tablets and smartphones. So the sensor equipped internet-ready device of tomorrow will include everything from automobiles and biomedical devices to household appliances and natural ecosystem. And the migration there are in the IPv4 and IPv6 coexistence, there are the migration techniques can be divided into three categories. It is the dual stack, the tunneling, and the translations. So dual stacks allows IPv4 and IPv6 to coexist on the same network segment. So dual stack devices run both IPv4 and IPv6 protocol stacks simultaneously. And for the tunneling is a method of transporting an IPv6 packet over an IPv4 network. So the IPv6 packet is encapsulated inside an IPv4 packet, so similar to other types of data. And for the translations, network address translations or 64 NAT 64 or NAT 64 allows IPv6 enabled device to communicate with IPv4 enabled device. So using the translation technique similar to NAT or NAT for IPv4. So an IPv6 packet is translate to an IPv4 packet and vice versa. So we have the um, for the connectivity verification. So the ICMP V4 and ICMP V6. So although IP is only best effort protocol, the TCP and IP thus provide for message to be sent in the event of certain error. So these message are sent using the services of ICMP. So the purpose of those this message is to provide feedback about issues related to the processing of IP packets. So it's under the certain condition not to make IP reliable. So the ICMP messages, it is at the ICMP messages are not required and are often not allowed within a network for security reasons. So the ICMP is available for both IPv4 and IPv6. The ICMP-v4 is the messaging protocol for IPv4. So the ICMP-v6 provides the same services to IPv6 but includes additional functionality. So the informational and error messages found in ICMP-v6 are similar to the control and error message implemented by the ICMP before. So, however, ICMP V6 has new features and improved functionality not found in ICMP before. So, the ICMP V6 message are encapsulated in IPv6. So, a message between an IPv6 router and an IPv6 device. So the router solicitation or the RS message and the router advertisement or the RA message the messaging between IPv6 device. It is the neighbor solicitation or the NS message and the neighbor advertisement or the NA message. So we have also for the address solution and the duplicate address detection. So the DAD or duplicate address detection, it is not required, but RFC 4861 recommends that DAD is performed on unicast addresses. So so like what I said, ICMP, it is available for both IPv4 and IPv6. So the ICMP v4, it is is the messaging protocol for IPv4. So ICMPv6 provides the same service for IPv6 but includes additional functionality. So that's all for the chapter 7 summary. So I hope you learned something and thank you guys for watching.